So we have example. So we have the following equation. Solve the equation. Du over dx minus 2 over x plus 1 times y is equal to x plus 1 to the power 3. So as you can see, this is a function p of x and this is a function q of x. They are known, and now we are looking for the solution y. Look for y of x. So put u is equal to the multiplication of two functions u and v. So what you will have is that du dy over dx is simply equals to u times dv over dx plus v times du over dx. Now we replace such functions, the derivative of u over x into our equation. We get so u times dv over dx plus v times du over dx minus 2 over x plus 1 times u times v is equal to x plus 1 to the power 3. So we continue. Now we factor u out and we get dv over dx minus 2 over x plus 1 v plus what remains is this guy here, v times du over dx, and all of this is equal to x plus 1 to the power 3. Next, we consider this part equal to 0. So we have dv over dx minus 2 over x plus 1 v is equal to 0, and this leads to, when you take 2 to the other side you get dv over dx is equal to 2v over x plus 1. Now you multiply by dx and divide by v, you will get that dv over v is equal to 2 dx over x plus 1. Now this is a separated differential equation. You could simply now take the integral on both sides. So integrating by integration, you get here ln of v is simply equals to 2 times ln x plus 1. Now you take the exponential and you get v is equal to x plus 1 to the power 2. Okay, so this is the value of v. What remains now is to find the value of u. Notice when we substitute v in our equation, when you substitute v, this part goes to 0, so what remains is this part, which is v times du over dx is equal to q. So now we have v times du over dx is equal to x plus 1 to the power 3. And remember that u is equal x plus 1 to the power 2 du over dx. So we could divide by x to the power 3. We could simplify those together, and what remains is du over dx is equal to x plus 1. And now you integrate, you get u is equal to x squared over 2 x squared over 2 or simply plus x plus c. Also a similar solution, you could also rewrite it like this. It is x plus 1 if you integrate with respect to x plus 1, which is the same, over 2 plus a constant c. Those two are possible solutions. They are both correct. Now, since we get the value of u and the value of x, now our final solution is y equals v times u, which is, what is the value of v? So the value of v is x plus 1 to the power 2 Now what is the value of u, which is x plus 1 to the power 2 over 2 plus a constant c. Now you distribute on both sides. You will get that u is equal to, y is equal to x plus 1 to the power 4 over 2 plus a constant c times x plus 1 to the power 2. So, and this is the final solution that we are looking for to our equation y prime minus 2 over x plus 1 u equals x plus 1 to the power 3. Okay. Also we have a remark. Is there any questions till now? So I will continue. In practice, we often encounter this equation du over dx plus a constant a, not a function of x, times u equals a constant b. A and b are constants, are real constants. So this is very easy to compute using the substitution or by separation of variables. What you get is du is equal to, you take this to the other side, you will get minus a times u plus b times dx, and now you substitute by this guy, you get du over minus a y plus b equals dx, and now you substitute, you take the derivative, by integration you will get minus 1 over a times ln of a y plus b is equal to x plus some constant c. You multiply by a, so you multiply by minus a, you will get ln of a, when you do the integration here, what you get? Anyone answer the question, please? If you take the integral of this guy here, what you get? It is not a here. So you will get here minus, so you should divide, and before taking the integral on both sides, you should multiply here by negative a, so we should also divide by 1 over minus a, which is this guy here. Then this is here inside the logarithm, we have minus a times y plus b equals, so we multiplied here by minus a plus c, and this when you take the exponential on both sides, you will get that minus ay plus b is equal to equal to exponential minus a plus a constant c, and now you solve for y, so you will get y is equal to minus 1 over a times exponential minus ax plus c minus b here, and this is the final solution. Okay, now this solution, now you could take this here, and the solution will become something like this, and distribute the a, so you will get a constant k exponential minus ax plus b over a. Okay, so if you have a and b as constants, so if you have an equation like this, y prime minus 3y is equal to 49, for example, this will give you, the solution will be without any steps, yx is equal to some constant k exponential minus 3, which is 3x, plus b over a. b is minus 3, so it is minus 3 over 49. This, you will need this in practice. If you have a first order with constant coefficients, it is easy to find the solution. Otherwise, you should apply the methods that I have given you. Now we go to exercise number 3 of our series of exercises. So, exercise number 3, we have the first equation to solve is 1 minus x squared